warm welcome to everyone. Today we are going to look at the statistical package for social sciences, which is popularly called SPSS. It's one of the tools used in statistical analysis. So this is going to be a tutorial on how to get acquainted with the SPSS and also how to use the SPSS when you need to process your data, summarize your data, and present your data, both for research and also for communicating your findings to other people. Just to put or lay down some points here, SPSS is not a magical tool, as well as other statistical packages that we use to analyze data. They are not magical tools in any way. What they do is based on our data analysis plan. So at the conceptualization of your research, you should consider the data analysis plan that will take place in the course of the research, which will stem from what makes up the variables in your research, what is the causal relationship between your variables, what is the independent variable, what is the outcome variable, there are other covariates you may wish to consider. All this builds into your data analysis plan and help you to determine what type of analysis that will take place. SPSS is just a tool that will help you to process the analysis. So today, I'm going to introduce you to SPSS, which is one of the many statistical tools available. And shortly, I'll be sharing my screen with you. And from my screen, we'll be able to go around the basics about SPSS. Okay. All right. So, so the first thing we'll do now is for me to share my screen so that everybody can follow. I hope we can all see my screen now. And the first question we may be confronted with is, how do I get SPSS into my system? The answer is simple. You will have to purchase SPSS from IBM, the current owner of the software, online. That is the recommended way. That is, or probably your institution have access, so you can log in using your identification number, and then you have access to SPSS. Okay. I'm aware that some other people can get the SPSS software from local vendors at a very reduced cost, which is actually against copyrights. So we don't encourage that, and such software are not stable enough to support your analysis later on. So it's always better to get from the right source so that you know you are dealing with the right package, and then with all the right functions, and then you have right respect for copyright regulation and respect for those who have given us the SPSS. So if you successfully have installed SPSS in your system and you want to launch SPSS, first thing you need to do is to go to your Start button. You click on the Start button, and then you simply look for the SPSS icon, which is here, and then you click on it. Why the system is booting is also necessary. I explained to everyone that SPSS was the brain work of some postgraduate students in Stanford, led by Normality in the middle stroke late 60s. And Since then, earlier on, it was known as a statistical package for the social sciences. However, it was bought over by IBM and named IBM, simply IBM SPSS Statistics, and then you include the version. So the current version is version 26, released last year in April. However, for the sake of this tutorial, if you have between version 17 upwards, then you can cope with the basics that we are going to do. We don't encourage use of any version below version 16. Okay, so my SPSS is still loading, so I'll still take more time to explain that there are other statistical software that you can use aside SPSS. We have EpiInfo, developed by CDC and WHO. And then for epidemiological informations, we also have Stata, SAS, and R. These are programming languages in a way. So you may need to write some codes, which is why they are a little bit different from SPSS. SPSS uses this beautiful graphical user interface where you just point and click icons and then you get your work done. However, even in the SPSS, whatever you click has a language behind it, which is referred to as a syntax. So that's a little bit of introduction. So let's go right in. So this is SPSS displayed. This is how it will open up. Now there is this dialog box here. So I encourage you to just close it by clicking here, close. Yeah. And then you have this beautiful spreadsheet. This spreadsheet is called Data Editor, as you can see written on top. Yeah. Okay. Data Editor is where you do a lot of the interaction with SPSS and do a lot of your work. The Data Editor is one of about 4 windows that you have in SPSS. If you click on File and you click New, you see that there are other windows. So this is just the Data window, Data Editor. There is Syntax window. There's Output window where you view what you have, the commands and the executions, they are displayed. And then you have the scripts. So the data window is where we are now. And data window has 2 views. As you can see down here, the data view and the variable view. And they are both spreadsheets, but they do different things, okay? So a quick introduction of this data view of the data editor window. At the top here are menus where you can have access to the options and functions available in SPSS to process your data. Below that is a set of icons which are just some of the options in the menus brought out here for ease of access. For instance, if you click on the menu view, you see that this drop-down menu has options. One of these options is value labels. And it's the same thing here, value labels. So we just brought it out for ease of access, okay? So what makes up the data view? Like I said, it's a spreadsheet made up of rows and columns. Rows and columns. The rows are the horizontal lines, columns are the vertical lines. So the rows represent your respondents or your participants or subjects in your study. So this subject or participant or respondent 1, this is 2, 3, 4, down. Now, each of the columns represent their responses to given variables or items in your collection tool, which may be a questionnaire, a form, or whatever means you've used to collect your data. So the variables or the items in those forms or questionnaires used for your interviews are represented by the columns. So the first variable is their age, it will be here, the sex, level of education, residence, and so on. Okay, so for each of the respondents, there are cells where the rows and the columns meet. Now, these cells can contain numbers, in which case we refer to them as numeric, or they can contain alphabets or a combination of alphabets and numbers, referred to as alphanumeric or string. And then it can contain other characters like dates and so on. We can also program these cells to take formulas. Maybe you have height, you have weight, and you want to compute BMI. You can program the cell to compute it automatically, and it will take it. So this is the data editor view, the data view of the data editor window. This is where you do most of the things that, most of your interactions with the SPSS. Okay, so at this point, I think we want to know, how do we get data into SPSS? How do we get data into SPSS? One way that we get data into SPSS is to import data into SPSS. Probably the data has been recorded in other file formats, like Excel most commonly, or whatever format. So if you want to bring that data into SPSS, you go to File, and there's an icon there for an option for imports. And then you go to the whatever file formats that your data is existing in. This is Excel format, which is common. So if we click on Excel, and we expect this to happen, to give us a dialog box, then we simply navigate to where the Excel file is in our computer. So I'm going to navigate to where I expect mine to be. And for all intents and purposes, mine should be under, where do I get it now? Let's see. Let's say we go to COVID-19 here. Let's click on research and see, yeah, there's an Excel file here. So if I click on this Excel file, it appears in the file name and the file type is well stated. So if I click open, it will give me another dialog box that will help me to properly specify what I want. So this dialog box, this is it here. Yeah, this is it. So you see there are some options here which you should pay attention to. First of all, you have to ensure that the appropriate sheet is what you want to open in the Excel. This is it. Make sure by default it should pick the appropriate sheet, but you must confirm. And then it's usually by default, you read variable names from the first row of data from the Excel. In the Excel, the first row usually is the variable name, the first row, if you look at Excel, the way data is captured. So you have to tell the SPSS that, look, you want to read that first row and use whatever is written there as the variable names, okay? Yes, and that's the most important thing you need to check there. And then you click OK, and it will import it in, yeah. Now, interestingly, this is another view which just disappears now, but I'll go back there briefly. Yeah, this is another view. It's called if you look up here, it's called the viewer, output viewer. So this is another window in SPSS that we have already said earlier. It tells you in kind of in a syntax. Syntax is the rules governing the language, in this case, computer language program. So in SPSS, whatever you do, there's actually a computer program behind it, or a computer language rather. So this is the language. So for the import we just did, this is the language. So, and so it is displayed in the output viewer window. So the output viewer window gets to show you a lot of things that you do, what is happening behind the scene, and it can also display tables and graphs and so on, so that you can visualize what you are asking the SPSS to do. It gives you a log where you can see every action you've performed, and then you can click on any specific log to see the particular output. So we are going to minimize this viewer output window just by clicking minimize, and then we'll go back to the data view in the data editor window, and you see SPSS has imported the data for us. So this is what the data, and you notice that it has used the first line to represent the variable names. So the variable names have taken the first line names from the Excel. So this is one way that we import data into SPSS. Simple, clean, and sweet. So you make sure you check to be sure that all your data came in and make sure they are all well represented. However, there's a second way of getting data into SPSS, which is the direct way, which most times many of us use. we go to the field with our questionnaire, we collect the data, and then we want to now enter the responses of the data into the SPSS directly. So which is what most of us does. And today we are going to go through that exercise to see how you do that. To do that, you need a new spreadsheet by going to new and data, and then a new spreadsheet will come up. Click, just like that, simple. And then you have this new spreadsheet. Remember, the old spreadsheet is still there. This is it here. You can, at this point, decide to close it. It will ask you if you want to save it. We don't want to, so you click no. So we now have this new spreadsheet. Please, before you close the old spreadsheet, remember to open the new one, okay? Now, so this is the new spreadsheet, and how do we enter data from our questionnaire into this new spreadsheet since we are not importing data? First thing you have to do is to let the SPSS know what the variables and the items in your questionnaire, what they mean. You have to let them know let SPSS know what they mean. And to do that, you go to the variable view. This is the essence of the variable view in the data editor window, okay? So you click on it, you notice that it's still in the form of a spreadsheet. However, this time, these rows represent the variables, not respondents. The variables, the items in your questionnaire. And the columns represent the characteristic of the variables or items. So the columns help us to characterize the variables, okay? So for this purpose, we are going to use a questionnaire built to assess the individual and family impact of this COVID-19 mobility restriction measures, which was developed by myself and my team. So I'm going to attempt to open that particular variable questionnaire so that we can see how it is structured, and then we also have access to see how the variables are. Let's see, so go to COVID-19 and see if we can get the questionnaire. Click on this. Yeah, so this is a copy of the questionnaire here, assessing family and community impact. So I'm going to click on it and see how it turns out, and so that everybody can see exactly what are the items or variables in the questionnaire, okay? This is not what we are looking for, so I hope it's coming up. Yeah, this is one of the work we are working on currently. So let's see what happens. Okay, this is it here. So this is the questionnaire that we are working on. And if you can see, it's assessing family and community impact of COVID-19. The first item or variable there is sex, and the responses can either be male or female. Then we have age, as at last birthday in years. Age group, okay, it's actually a probe variable. Probe variables are variables that help you to authenticate other variables. So this is a probe variable for this. Then the highest level of education attained. The responses or categories are either formal, no formal, primary, secondary, tertiary. Usual place of residence. This is an open question, so you have a lot of alphanumeric or string responses here. Then employer type or type of business. Is it public, owned by government, you work for government or private? Number of people in your household, which is an open, it's open so that they can put the number directly. Do you believe that coronavirus is real? You say yes or no. response to that question. What social distances measure are in place where you live, and then how has the lockdown affected your source of income, and so on. You see, it's all through down to question 18. So we have 18 items here. So now we're going to do a demonstration of the first. Let's see, we'll do a demonstration of the first five items of variables. You see, and then after that, we'll also show you the actual data modified for this tutorial. But let's see, how do we code these first five? Remember, sex, male, female, age as our last birthday. We're going to skip this probe question, and then we'll go to highest level of education attained, and the usual place of residence. So those are the questions we are going to use for our exercise. So now let's take a look again, and let's see. So remember this, because I may not be able to go back to this questionnaire again. Okay. All right. So knowing that, we can move forward a little bit and see what. Okay. So how do we code? Now, the first thing is to remember the first variable or item there is sex. We usually don't start the name with a number, and in the course of the name, we don't use spaces. So for the first one, I'll simply say question, which is Q. I'll represent sex as Q0001. That's just a name. Notice I started the name with an alphabet, not a number, and there is no space in between. If you actually write something like this, which most of us are tempted to do, sex of respondent, assume, you notice that as soon as you decide to move to the next cell, you have this error message which tells you variable name contains an illegal character. That illegal character is actually the space that you've introduced. So it doesn't take space. And neither do you start it with a number. So what we should do is just write an alphabet, in this case Q, would represent question, and then 0001. That's question one, essentially. Then how are we going to enter sex directly into the data view? We want to make sure we represent males as 1 and female as 2. So we're going to use numbers to enter it. So here becomes numeric, like I've said earlier. What determines why numeric or string is how am I going to enter the data into the data view? You must answer that question. As soon as you answer that question, it helps you to make a decision. If I'm going to represent male with 1, female with 2, and I'm going to enter it like that in the data view, that's numeric. However, I can decide to represent male with M and female with F, in which case that will be string, okay? So the width tells us how big the column should be in the data view and how many digits it will contain. But we're not interested in that now. We'll just leave it as a default of 8. Decimals, we don't need decimals here, so we'll take it to 0 because it's just male 1, female 2, so there's no decimal. Label is where you are actually at liberty to write whatever you want to use in representing that variable, in which case this is sex of respondents, okay? Simple as that. And what are the values? The values are either 1, which is male, like we have already agreed, and 2, which is female, okay? And then you add. And okay, so the system now recognizes that anytime you enter 1 is male, and anytime you enter 2 is female for the column that represents sex in the data view. How did I get here? Just click at the right end of this cell here. And this dialog box will appear, and then you fill here 1 and you give it the variable, the label, and so on. So it's a simple process. You can do it. We won't bother much about missing, but along the line in other subsequent videos, we'll focus on that, especially in the advanced course. Column and width are essentially working together. So by default, we just leave them as 8. Alignment it just tells you how your letters or your numbers should align in the columns that represent variables. But we are not interested in that. It doesn't add to the statistics. At the most, it adds to the cosmetics of your spreadsheet, or the aesthetics. Then here, these two last rows are actually, you need a little bit of a knowledge of statistics to be able to indicate what you want. Sex, as we know, for those of us who have been introduced to the type of data that we have, sex is a categorical data of the type of nominal. So you have to indicate that there. Row tells us the type of variable or how it is being used in the research. Is it as an independent variable or as a dependent variable? And those two terms, by now, we should be conversant with it because we have already looked at it in the earlier videos and earlier lectures. So if you click on this tells us exactly what it should be. Input represent independent, target is the dependent. If this variable represent both, then both dependent and independent at the same time, you click both or none, and so on. So for the sake of moving forward, we'll just leave it as input, okay? So the next is age, if you can remember, in years, as at last birthday, which is actually a whole number. So we give it Q0002 as question 2, we'll move. Since we are going to use numbers, actual numbers, to represent the age of our respondents as provided by the respondent in the questionnaires, so it becomes numeric. I hope this pattern is clear to all of us now. When do we say numeric and when do we say string and so on? Because sometimes that may be very confusing for most people, okay? We don't bother much about it as usual, and since we don't have whole numbers with age, we just take it to 0. And then here, we just give it now the age of respondents, okay? Sometimes you can go for that to say in years, okay? Yeah, so that's how SPSS will now label that particular variable. Values, we don't need to represent age now with values. Why? Because it is not categorical. Age is a numerical data. Same thing, we don't bother about missing, column, align, but we bother about measure because age is a numerical variable of the type ratio. Numerical variable can either be interval or ratio. However, a numerical variable in SPSS is represented as scale. And you see a ruler there will help you to actually point you to what it is. You know, it's a scale data set, scale data, and that is a combination of interval and ratio. So we'll click that, and then by default, we'll just leave it as input. Third one is level of education or formal education that has been achieved by the respondents. So that will follow in the same pattern. We just give that QQ03. Now, by all means, this is dependent on you. You can give it any name that you want. In this case, we are going to say 1, representing no formal, 2, primary, 3, tertiary, secondary, and 4, tertiary. You can give it any codes or any values that you want, but it must be sequenced. It must be in a ranked pattern because level of education shows ranking. Okay, I hope that makes meaning to us. So, but for the fact that we are going to use numbers to represent these categories, then it is numeric. So we skip this, we take it to 0. We don't need fractions. Here it becomes highest educational attainment or attained, okay? Here, so we are going to provide values by just clicking at the right-hand end here. of this cell. You click there, this dialog box shows up. Put your cursor on add and leave it there. Just put your cursor on add and leave it there. So the first variable is 1, which represents no formal education. Just type it in to the space for label. And then you hit your enter button. Hit your enter button on your keyboard and it goes. Second value represents primary. Okay, hit your enter button and it goes like that. Third represent secondary. Hit your enter button. Fourth is tertiary. Enter button, and that is it. It's at this point you can now click OK, and the system has accepted it. So missing, column, aligned, we know the usual. Then under the measure, look, the level of education or formal education attained is a ranked data set. So, and it's also categorized. So that puts it in a unique category called Ordinal Data. So if you click here now, you notice this is the ordinal, so you put it there. And this is very common, especially in medical and clinical research, where we often rank our patients as mild, moderate, or severe. Or we want to look at the stages of diseases, especially cancer, stage 1, 2, 3, 4. So anytime we attempt to rank, then that is ordinal, and we must represent it appropriately. Okay. So the fourth we'll deal with is the question, actually, which is question 5, if you can remember, but we'll just call it 4. And here, that question that deals on where they reside, place of residence. And if you remember, it's an open question. We expect the respondent to fill it in by themselves. So we are going to have huge variability in terms of their responses. And we expect them to write it in words, and we're going to enter it into the data view in words, so not in numbers. So that tells us that the type of variable is going to be string. So by the time you click this edge here, this dialog box shows up, and then you can click string and click OK. And you notice automatically you do that, the measure turns to nominal, because strings are nominal, okay? And then you have to indicate here the label, which is place of residence. There's no value because people write as much as they can, so just make it open. But please focus on why it is string. It is string because this is words. They are going to write it. So if they stay in Benin City is written in the data view. Remember, this is telling us how you are going to enter the data into the data view. Don't forget. So if they stay in Lagos, it will represent Lagos. If they stay in Rivers State, it will represent that you put it there. If they stay in Delta State in Nigeria, put it there. So all those are the things. So this is how you code your variables. So here we've coded successfully for variables. Now let's see how this now plays out in the data view. So you go down here again, click on data view, and you notice that the variables have taken the name that we've given to it. So all the variables have taken the names that we've assigned. So this tells you are doing a great job. So the next thing will be for you to actually enter the data. So for the sake of this exercise, you are going to enter data for the first 5 respondents. Remember what each of these variables represent. In case you forget, what you simply do is to put your cursor on top of the variable name and to tell you what it is. Just like that, it displays it. So this is sex. Let's see, put on top of this, age. How about this? Highest education attained. How about this? Place of residence. So let's do the data entry. So for this first one, let's assume we are dealing with male 1. Next thing is age, 34. Highest level of education attained, tertiary. Place of residence, Benin. Second is still a male. Age is 40. Education attained, secondary. Place of residence, Warri. Next is female. Age, 32 years. Level of education, tertiary. Place of residence, Lagos. Next is female again. Age is 50 years. Education attained, primary. Place of residence, Kaduna. Next is another male. Age 57 years. No formal education, 1. Place of residence is Maiduguri. And now you notice I couldn't spell Maiduguri all the way. And this is something you need to, this is reflecting the role of width and column in the variable view. We've indicated by default that we need that the width should be 8 and the column should be 8. So what that means that since we said the width should be 8, it can only take 8 characters. However, Maiduguri is more than 8 characters. Maiduguri, I think, is up to 9 characters. So it can't take the last alphabet in that word, Maiduguri. So what do we do? If you really want to make sure you represent the words to its fullest, the way it is written in your questionnaire, then you go back to variable v again, and for string that has 8 width, you can take it to a higher value. How do you do that? This top right corner of the cell, click, you see that there are direction signs, up, down. So you take the one up, I want it to be up to, let's say, 15, like that. Usually, I like indicating the column and taking it to the same number, 15, so that we can see it. So if you go back to your data view, you notice that this column has expanded to 15. You see, it's bigger now, bigger than the other ones. It's bigger. And you can actually complete your spelling with the I, and it will take it. So that's the importance of the width and the column. I hope that's clear a little bit. So these are the 5 respondents, and we've entered their characteristics using 4 variables, as you can see, for each of them. So now what next? What do we do? What do we do? What next? You can take a quick look at your codes to be sure your codes are in order by going to variable label, which is this. Just put your cursor, it will display what it means. If you click on it, yeah, it shows you what the labels are for the values or the codes. And if you click it again, it takes it back. So you're able to just play with this to see what is going on. Please, there's something I want to stress here. When you are entering your data, make sure your value label is not in the label view. Your value label should be in the value or codes view, because you're going to enter the codes. If it's in the label view, look at what will happen. Let's assume we had a 6th respondent. If I click and I want to enter, this respondent is male, and I say 1, it gives me something like this. And it can become very confusing. It tells you to select from the categories you've already programmed or coded for sex. So you have to click and then click male. That's a long process. Okay, that's very long. So to avoid that, make sure you convert it, make sure it's in the code format. Make sure it's in the code format. And then you can just put 2 like that and you move on. Okay? All right. So this is the first half of this whole introduction to SPSS. Just to recap, SPSS is one of many statistical packages for data analysis. SPSS initially meant statistical package for the social sciences, but after being bought over by IBM, the name is simply IBM SPSS Statistics, and you add the version that you have. Current version is version 26, released last year. But if you have from version 17 upwards, the functions are good enough to perform any statistical analysis. And we have also been able to look at the SPSS windows and the working environment. Specifically, we focused on the data editor window with the 2 views, data view and variable view. We have been able to demonstrate how to import data from other files into SPSS using the file import option, and then you choose the type of file that you have. And then we've also demonstrated how to enter data directly into SPSS by first making sure the variables are coded in the variable view of data editor, and then you enter the data. So we're going to move over to the second segment of this tutorial, and that segment deals with how to do what we call data cleaning and so on, how to do data transformation and other functions that you may need to do with your data already in SPSS. So for us to do that now, I'm going to quickly open up this same data sets from the same questionnaire, but this time with all the respondents for that research captured in the data view, and some variables have been modified for the purpose of the lecture of this tutorial. Okay, so I'm going to quickly open that up and then I'll close this particular spreadsheet. So let's go to my file. I want to open a new data. So I'm opening now. This is not new, sorry. It's an existing data, so I don't use new. I go to open. So you use open when you already have a data existing in your computer. So this is open data. Because I want to open a data, I click on data. Sorry, that's not what I should click. It is file, open data, data. Yeah. And it shows you something like this. Okay. Shows you something like this. So here I already have data sets that are existing. So I'm going to decide which one I'm going to really use. So I have to look for the data not in this folder. I'm going to look for the data I want to use. So in your own system, you look for your data where you stored it. Can be in a folder for your research or something. So for mine, I'll just move up a little bit and see if I can, my lectures. Let's see what is in my lectures. Okay. Yes, the statistics in medical research. Try and open that. Then let's look deep into it. Yes. So this is Greg Starts Lab SPSS. I think that should be the data I'm looking for. Click on it, it appears here. I tell you the file type. So the SPSS file extension is the .sav or .zsav. These are S. So anytime you see this file extension attached to any file name, it shows that that file is an SPSS file. And such, it can be opened in the SPSS environment. Okay, so I'm going to open now, and I'm going to have a display of, yes, this is the data set. This is the data. So the same thing, if you notice very well, yeah, some little amendments and all that, but this is the data we are talking about, okay? So I'm going to close the earlier sample data so I can have more space for my SPSS, for my computer to work. I'm not going to save, so don't save, no. So I'm going to, at the end of this video, show you how to save. Saving is practically the most simplest thing everyone should be able to do, okay? Okay, now let's see. So this data is already entered, it's in my system. We'll follow the procedure of variable coding to data entry and everything. So now what next? What do? I can simply click on value label to see what I have. And then you can see, so same thing, sex, age. Notice this age has decimal and it's making it untidy. So I can simply go to variable view. First of all, I'll give it a proper name. Let's call it Q0002A, just for the purpose of this tutorial. And you see the decimals here is 2. So I have to take it to 0 and then give it a name, age of respondents. I'm doing this because sometimes you may get data and some things are not in shape. So as part of data cleaning and general housekeeping, you must do all this. So I've given it a name, no value label, age is scaled, so everything is all right. So you must do this. You must always check your data to be sure the variable codings and variable labels and everything is in order. You must. Let's go back to the data view now. You notice age is now more tidy, no decimal. That's taking the name we have given it, and it's looking good, okay? Yes, so part of the housekeeping you must do is to give your respondent unique identifier. Very important. How do I mean? What's a unique identifier? Unique identifier are numbers like identification of a given respondent in your data set, unique to that particular respondent. These numbers here, if you look at this rule, should have been the unique identifier, but this is already set by is programmed into SPSS. So we cannot really manipulate this. We need a unique identifier that we can manipulate, that we can use flexibly. So we have to create our own unique identifier. How do we do that? Put your cursor just above the name of the first variable. You right click, and then you click Insert View Variable. And the SPSS will give you a new variable to the left of the former variable one. You can see it just this way. Okay, I can also do a deletion by putting my cursor on top of this variable, right click, and clear. If I click on that, it will disappear. So this is how you actually create and delete variable directly on the data view of SPSS. So let's do it again. Right click, insert variable, and then you have this. So this is a new variable now that's going to represent our unique identifier. We want to give number 1 in the identity of 1. Number 2, identity of 2. So it should be 1, 2. So we can just say 1, 2, 2, 3, 4, 5. You notice this is going to be a very cumbersome exercise. So for us to do it smartly, you need your Microsoft Excel. Excuse me. And so this is my Microsoft Excel here. So you simply open yours, you click on it, and then it displays. And then pick any cell. I'm picking this cell. And then I type in 1, like that. Go down to the next cell, 2, like that. So I have 1 and 2. And then I highlight both, like that. I put my cursor at the edge, the lower edge of the second cell, just there, and wait until I see this black cross. See, it becomes black. You must wait until it becomes black cross, and then you click right left click and hold down. Left click and hold down, then drag it. So you drag it to the number that you want. For our case, our sample size is 523, I guess. So we need to take it down to 523. But I'm going to, then it will give us the exact numbers that we need. Make sure you left click, hold down, and drag. So that's what we are doing now. So we are dragging, firmly dragging until we get to 5. Good, that's 5, 2, 3 there. But I'm going to go one step below, and that is it. So I've gotten my numbers from 1 to 5 to 3. So this is how helpful the Microsoft Excel can be. So what you have to do is right click on it and copy. That's all. And then you simply go to your SPSS again. Click on the very first cell in that new variable. Right click. And then from the options, you choose paste. And that is it, you have it. So it has pasted and given unique numbers to everybody. So 74 still remains 74, 80 still remains 80, 81 still remains 81. But this is the one that you can easily manipulate this. You cannot manipulate this. This is programmed to the computer, to the package. But this you can actually manipulate. You notice there are decimals and all that. We have to tidy that up and we have to give this a name. And where do you do that? You do it at the variable view. So you click on the variable. That's our new variable there. So we can give it unique, just like that, underscore ID, unique ID. Remember, no space, so we have to, but you can use underscore. And then you take the decimal to 0, don't need that. And so this will be unique identifier. That will be our label, okay? No values, and of course this will be nominal because this is just categorization of people by unique numbers. It's not a rank, so it's not ordinal. Neither is it scale, just categories unique to each person, okay? So if you go back to variable view, everything is there now. The variable name, unique ID, and then a tidied up numbering without the decimals. So at this stage, I can say we are good to go. So we can, this is part of the housekeeping you must do before you start your analysis. Remember, this is showing the labels for the codes. So if you want to leave it like this, no problem. If you want to take it back to the code, you just simply click the value label here, like that. Takes it back, bring it back. Okay. So the next thing we need to do at this level is what we call data cleaning. Data cleaning. How do we, what does it mean? Data cleaning simply means going through your variables one by one, your data sets one by one, ensuring that you did not enter a value that is not real, or a value that is an outlying variable by mistake, you entered it. So you want to check from each variable. So you run an analysis, a quick one on each variable. So let's start with the first variable that we have here. And what's the first variable? Question 1, sex. I must say, make it clear here that for the categorical variables, you run frequencies on them. And then for the numerical variable, you request for descriptives. How do I mean? So this is where your analyze button comes into play. That is it there, which is one of the most powerful menus you have in SPSS, because it contains all the statistics, functions, and so on. So if you click on it, just like that, you have this list of functions for statistical analysis. We are taking the second option, descriptive statistics. We click on frequency like that. Remember, sex is categorical. We can only run frequencies for them. You click on that. It gives us this dialog box. You are to look for sex there. This is sex. Use this direction sign to take it over to the variable box like that. And then you have at this top right-hand corner, these buttons. Let's explore some of them. Statistics. This tells you if you want to order for any statistics to be done on sex. Since sex is a categorical data, none of this will be applicable. Okay, so we just simply click continue. How about charts? We may be interested in charts. However, I must say that bar and pie charts are for categorical variable, but histograms are for numerical variable. So it will be inappropriate for you to click histogram for sex. So we are going to click pie. And it gives us our charts using the frequencies, not the percentages, frequencies. So it uses it by number of males, number of females. Those are what it will use to present the charts, not percentages, okay? So you click continue. These are the only two we'll explore for now. The others, you can check it out yourself and see what they have for us. Now let's click OK. As soon as you do that, you remember this window again. This is the output viewer window. So where we view the commands that we've given, okay? So here now you see SPSS have displayed tables for sex. And usually the first table is the summary table. It tells us quickly how many people we are used in our data sets to do this analysis, and that's represented by valid. And can you see this, everyone? It's 523, which is our sample size, right? Yes, but there are still missing 6 people. So how come? Does it mean our sample size was more than 523? Where are these 6 people coming from? And it's still reflecting in this table here. So before we go further, we have to find out what's going on. This is the essence of data cleaning. So you minimize this output and we'll go back what happened to sex. So let's go down to the end and see there's an issue somewhere. Okay, let's go and see what do we really have. Let's see. So, okay, now we've gotten to the end. It's clear that there was an issue here. We are expecting to stop here, but by somehow there are still some entries just for age, which we don't need. And with dots everywhere, SPSS still sees dots as an entry. So it will add it to your sample size, thinking is an entry. Look at the dots. And these dots were generated because there's an entry for a variable. So every other variables expect that you should put something for them too. So how do we do this cleaning? How do we clear it up? Simple. Put your cursor on the numbers where you want to start your cleaning from. Left click, drag down to highlight to the point that you want, and then right click. Drag down, then you right click and clear, and they are gone. As you can see, these numbers are no longer highlighted. They're no longer highlighted, so now we are safe. So this is part of the data cleaning. Just this simple exercise have helped us to identify some entries which should not be, and we've taken care of it by clearing them out. So let's see, we have to reanalyze and see if what we've done has been affected properly. Still go to frequency. Now, this variable here, which is still sex, if you just click OK, it will still give you the wrong output because it's still operating with the old memory. So you have to click on it, take it back to the pool of variables here, and then bring it back again to update the brain of the variable. That's something you need to do all the time. So if you make a change in a variable, even though you have used that variable for analysis before, by default, it will remain in the variable listing. You have to take it back to the pool of variables and bring it back again so that you can upgrade or update to the new changes that you've made. So every other thing here always remains the same, so we're not going to touch it. Just click OK this time and see what happens. Yeah. So this is the new tables that we have based on our commands. And you notice now that the missing has disappeared. It's now 0. And our normal sample size is there also. So if you take a good look, so how many males do we have? 258. How many females? 265. And in percentage, 49.3, 50.7 respectively. Okay, so if you are going to present your data, is the first 3 columns that we use. Or when do we use valid percent? We use valid percent when we have missing in our data set and we don't want to represent the missing in our percentages. So let's go up a little bit and see how we mean. Remember we had missing before we cleaned it up. In this case now, 6 people were missing. The percentage, if you look, the total percentage was 98.9. So if you use 48.8 and 50.1, you may not be absolutely correct until you include the missing percent before you can get 100. So to avoid all this, if you want to restrict your analysis to just the people who provided information, 5 to 3, you need to take the valid percent, which add up to 100. This is very key. Unless you go back and remove the missing the way we've just done, then you can take the percent column. Else, valid percent is what we need. Okay, when you have a missing that you don't want to represent in your tables. Okay, so SPSS also gave us this pie chart that we requested for. It's in 2D, which is also sufficient. It's very sufficient for your publications. But some of us may want 3D charts. Then you may have to consult other softwares that have that inbuilt capability, or you simply use your Microsoft Excel, which builds beautiful graphs also. Okay, so that's how you do cleaning for categorical data. How about numerical data? How do you do cleaning? Yeah, a good example is age. As you can see here, how do we do cleaning for age? In this case, we go to Analyze, Descriptives, and then Explore or Descriptive. Anyone can go, but usually we use the Explore option. The Explore option is always better. Okay, so we click on it, and this is age, put it over here, dependent area, you can see. And if you are interested in exploring age with respect to the sex categories, you put it here. So what that does is it explores age for males and age for females separately. It gives you the mean separately for male, female, and so on. The only thing probably it doesn't do here at this stage is it doesn't compute associations between sex and age yet. I don't think it does that. You may need to click on another option, not explore. Okay, this is just to explore your data, see how your data presents, what are the things there, and so on. So since we're not interested in by sex, we take it out and we just leave the age of respondents there. So let's request for some statistics if you want. We want outliers. Okay, continue. How about plots? Do we need plots? By default, the stem and leaf has been checked. but we still need histogram too, since we are dealing with a numerical data set. And then we want test of normality. If you're interested, then you click continue. These are the only two things I'll do. However, I must say that even though we click test of normality, there are three ways to check for normality of a numerical data set. First is by the graphical method, where you have to plot the stem and leaf, the box and whiskers plots, as well as some QQ plots. All this will help you to look out for normality in that given data set. In this case, we are focusing on age. The second means to check for normality is skewness statistic, which we are going to see shortly. And then the third way is by test of normality. And there are two tests that SPSS use, which is Kolmogorov-Smirnov and Shapiro-Wilk. But we are not interested in the test of normality because it has been shown that they are very sensitive to deviations on normality, too sensitive. So I will encourage us to always use the graphical methods and the skewness statistics. Those two are sufficient to help us make a conclusion on if our data set is normally distributed or not. That's stage one. And then you wonder, why do we need to know if our data set is normally distributed or not? We'll explain that shortly. So you can click OK here, and SPSS will display everything in the output viewer window. So let's see. It has used 523 people for this analysis and 0 missing. That is exactly what we want. It now gave us a table of the descriptives. A table of descriptives. You know, if you had click analyze and we click this descriptive, this is the only thing it will give us, this table. Or if you click explore, in addition to this table, to give you a lot of other tables and graphs. That's why explore is better than descriptive. Okay, option. Now, so let's look at this. The mean age is 42.31, the standard error of 7.742. Why are we interested in the standard error? Standard error helps us to compute confidence interval around our estimates, okay? So for age, this standard error was used to compute these two confidence bounds. We have the lower bound and the upper bound. What this tells us is what could be the true value for this sample mean, the mean, what could be the true population mean, or what could be the true mean in the source population that gave rise to this sample. The range of values that it could fall into, 40 to 43. That's one main information it can give us. So what could the range of values be in the source population for the mean estimate we have in our sample? Two, it can also help us to determine how precise our estimate is. 40 to 43 is very narrow. The narrower, the more precise. So which means 42.31 mean age is a precise estimate. But if you have a very wide confidence interval, that means there is a lot of noise and precision is low, okay? And remember, this is very dependent on your sample size, but that's a different lecture entirely. So this is the median, 39, variance, standard deviation, minimum, maximum. So our minimum age is 15, maximum 79. The range, subtract these two, is 64. Then the interquartile range, Q1 and Q3. If you subtract them, the difference is 27. And then this is a very important statistic, skewness statistic. Tells us if our age distribution, if it is skewed or normal. So with this, how do we use this? We'd have to divide the skewness statistics by the standard error. If we get a value that ranges between minus 1.96 to plus 1.96, then we can say age is normally distributed. But anything outside that range is skewed. This is the second way we check for normality. And how do we do that? We're going to divide 0.430 by 0.107. So I'm going to reach out for my calculator and do that division. We can actually also do that division using SPSS, but let's just do it here. And what are the values again? 0.430 divided by 0.107. And that gives us what? This gives us 4.018. That is outside the range minus 1.96 to plus 1.96. Therefore, we can actually assume that age is not normally distributed. It's a skewed data. And we're going to treat this as such as we go on. So the question is, what do you now do to a skewed data? What does it tell you when the data is skewed? It simply tells you a lot of things. It tells you how you are going to process the data moving forward, how you're going to represent the data for the scientific audience. So if the data set is not normally distributed or skewed, as the case of age now, we encourage that you present it using the median and the range, or the median and the interquartile range. That's the best way to communicate such skewed data. However, if the data set is normally distributed, the best way to communicate it is using the mean and the standard deviation. So, but in our case here, it is skewed. So the best way we're going to represent our data set is median and range. And this is very common in clinical research also, because most of the patients we use for our research, they are sick, and some of their assays and biological and biochemical parameters are deranged. So you see very skewed extreme values for some and very skewed to the lower values for some. Only very few people will have the normal range of values just because they are sick. So the assays and the serum levels of most of the substances in our body will be deranged. So expect to see a lot of skewed data in your biological sciences, especially clinical research area. Okay, so that's the second way you check for normality and the information it can give you as to how to present your data set. This is the extreme values that we have and the cases that represent the extreme values. Look at them there. And then this is the test of normality we are talking about. Usually it is significant, as you can see, p is less than 0.0000, whatever. So the Kolmogorov-Smirnov and Shaporovitz test, we usually don't use it. I've said this earlier before, so we just move on. It's a histogram showing how age is distributed. Remember, it is positively skewed, so we are expecting the tail to be dragged towards the right. So this is a right skewed or positively skewed data set. Okay. This is a stem and leaf plot, which is just like a histogram in a different direction. If you watch, it peaks and then goes down and it becomes heavy at the tails. It becomes very heavy here, move down, down. So this is also skewed to the right. This is the quartile to quartile plot, and what we expect here is that these dots should actually be along this straight thick line. But as you can see, that's not, just made an S around it. So that's another clue that our data set may be skewed. Same thing here, we expect these data points to be very close to this thick horizontal line, but this is not showing here, so which means somehow age may be skewed. It's a pointer. And then finally, this is the box and the whiskers. This is developed by Tukey, an American statistician, and it has a lot of information. First of all, this is the whiskers here, this is the whisker, and this whiskers, and then this is the box. So the whiskers information it gives us is the maximum value. You always trace it to the y-axis, okay, to get the value. So maximum value, if I track it here, that's about 79. Then the minimum value in our data set, track it here, that's about 15. Okay, so that's one information. And knowing that, you can now get the range, 79 minus 15, which is 64. Now let's move to the box. The lower edge here, horizontal edge of the box, represents Q1, which is quartile 1, first quartile. which should be somewhere in the neighborhood of 28 or 29 or thereabout. Then here, which is the third quartile or Q3, you can track it here like that. Maybe that represents probably 55 or thereabout. So knowing Q1 and Q3, we can get our interquartile range by subtracting. That makes sense, I guess. And then this thick line in the box, this is actually the median, not the mean, the median. Remember, the median represents Q2. Q2 is the median, second quartile. So this is the first, this is the second, and this is the third. The second quartile is the median, and we can actually track it in the y-axis to get the value, about 39 and so on. So this is how you interpret the box and whiskers plot. You can also use the location of the median in the box to know if it is skewed. We expect this median to be at the middle of the box, but in this case, as you've already seen, it is not, which means our data, which further confirms our data set is skewed. So this is how you present numerical data when you want to do data cleaning and explore them and all that. So knowing that, you're able to now to explore categorical numerical data. Next thing we need to know is how do we transform data? How do we create new variables? Okay, this is part of our introduction to SPSS. So let's assume we're interested in categorizing age, okay, and making it into categories so that we can present it in our tables or graphs. SPSS has inbuilt functions to help us do that. But before we categorize age, there are some things we need to know. First of all, we need to know what's the minimum age. We need to know what's the maximum age. And then we need to create the intervals beforehand. So are we interested in creating the intervals that, since our minimum age here is 15, our maximum is 79, what will you want to do? Do you want to say the first category or interval should be less than 20? The second should be from 20 to maybe 29. Third should be like 30 to 39. So we are using decades now of years lived. So if that's the case, so it's less than 20, 20 to 29, 30 to 39, and so on until you get to 60 plus, okay? So going by that, we are going to see how do we actually do it? How do we transform this into, and you can do it in two simple ways. First of all, you can decide to go to the next variable close to the one we want to transform. Put your cursor on the name of that next variable, click and click insert variable. So we just inserted a variable after age, which we want to transform. And then you go to variable view, look for that variable, which is this, give it a name, which is age underscore t, which simply means age transformed. Okay. And then take this to 0. Usual thing, give it a name, age transformed. That's okay by you. And then this will now become ordinal because we have taken in numerical data, we have ordered data and categorized it, okay? So if we go back to data view, so our new variable we've created has taken the name age underscore t. So what do we do next? We're gonna have to move further and call up the menu transform. These are all the options, but we'll click recode into different variable. Please, there is recode into same variable. That's not our focus. If you do that, your new coding will replace what you have already. But if you do this, it will create a new variable and add it to your spreadsheet. So this is preferred. So we click on it. We look for age, which is this, and we'll take it over. You notice that is asking for the new name with a question mark. So you come here and give it a new name, and I'm going to give it the name of this variable I've already created for it. So what's the name? Age underscore t. Label, remember label can be anything. So age transformed, and remember label takes space. So everything is possible with label. So age transformed. So if you click change, this question mark will turn into the name we have given. Let's try it. Click change. Yes. Now what this thing means is, we've already created a variable. So it's asking us if we want to replace that variable with what we are doing now. The answer is yes, we want it. That's where we want our variable. So this variable named duplicate our existing variable. We are okay with that. That's what we want. Okay. So it's going to output the new category in this one now. That's the meaning. Okay. Very close to the age. Then we'll go to old and new here, just here, to specify what we want. Click on range and say, okay, from 0 to less than 20, which is 19. I hope you can see the way I did that. 0 to less than, true to 19, because that's less than 20 is the first category. We'll give that a value of 1 and we add. Okay. And then the next thing is from 20, remember, to what? 29, I guess, which is the third decade of life. We'll give it 2. Add. What's the other ones? It's 30, yes. True to 39, yes. We'll give that 3. Okay. From 40 to 49, we'll give a value of 4. Okay. And then from 50 to 59, we'll give a value of 5. And from 60 to 69, we'll give a value of, let's say 60 plus. So let's say 60 to, make sure you give a number that contains every other remaining age group. Let's say 100. We know that the maximum is 79. So 100 covers everybody. So 60 plus, that's 60 plus. So we'll give it a value of 6. So what that means, we will now have 6 categories of age. Click continue. Click OK. Yeah, it will show you the syntax or the programming language in the output viewer. That is understandable, but just minimize that again so that you can see what you've done. And this is it here. So we've created successfully a new variable, and then we've transformed age into that new variable. So I encourage you to go through this over and over again so that you become perfect in it. So this is our new variable. So you have to make sure you don't just stop here. So you now go back to variable view. So this is the new variable that we've done. Where is it? Here. This is our new variable. Okay. And we need to make sure we don't give it a value since we've categorized it. Put your cursor on add and just leave it there. So we go 1, value of 1 represents less than 20. I hope everybody can remember that. That's what we agreed. Enter. Value of 2 is 20 to 29. Does that make sense to everybody now? Value of 3 is 30 to 39. Value of 4 is 40 to 49. Value of 5 is 50 to 59, I guess. Yeah. Hope you're in order. Then value of 6 is 60 and above, 60 plus. Enter. Good. So we've given it a kind of values and codes, and we can click OK. And let's go back and see how that plays out in the data view. Good. Have you noticed that the age categorized now have taken the name of the group? So 77 is actually 60 plus, 60 is 60 plus, 46 is between 40 and 49, 57 is between 50 and 59, and so on. So which means we have done a good job. And if you want to see the codes for these ones, as usual, you click value label and it takes you back and it brings you back. So that is data transformation. That's how you transform data, especially numerical data in SPSS. Okay, now let's assume we want to transform the categorical data. We just want to switch numbers. We want to do an analysis, or we are looking for a given value, and we want to switch numbers, or we want to do something. Let's take sex again and take it to the codes. So let's assume that we want to convert all twos to 0. Instead of 1 male, 2 female, one male, 0 representing female. So what do? Same thing. Make sure you identify the variable in the column and click anywhere in that column. It must be in that column, not in this, not in that, not in any other column. And then you put it there. You go to edit, which is there. You look for replace, and it will give you find and replace option. So let's say in the replace, in the find, I want the system to look for number 2 and to replace it with 0, just like that. Make sure that you click somewhere in the particular cell that you want to do that transformation. If you click another cell, to go and do it in that cell. So it must be that cell. This is the cell we are using, okay? Before you click anything, make sure this show options is interesting. Click entire cell, very important. And then the next thing you want to do is to replace all, find and replace all. So whatever it says 2, will replace with 0 in this particular column or variable. So let's see how it does that. So find 2, replace with 0. Click. It has done it. So it has replaced 265 replacements were made. Okay. Then you can close this up. And then if you look at it, all the 2s are now 0s. However, I will not stop there. We can go back here to the variable view and make sure we change this, we take it to 0. Make sure we change it. And you click change instead, not add, change. It takes it immediately. So 0 is now female, male is now 1. You click OK and go to data view and everything is here. And if you want to see what it means, you can click variable label. You see that it still remains the same meaning, but different numbers. So this is how we transform for categorical data. I hope we all enjoyed the second segment of our tutorial for today. We've been able to look at data cleaning, be able to look at how we clean categorical data, and then how we explore numerical data and data transformation, both for numerical and categorical data. I encourage you to practice as much as you can. Don't be shy to make mistakes. SPSS is a simple tool that anybody can use and anybody can walk around, especially this point and click. There are another aspect of it called the syntax aspect. It's more like computer programming, but it is very efficient and it's very replicable. It can help you to replicate your analysis many times over. So we are going to actually focus on that in the advanced course. This is a basic course and a basic introduction to SPSS. I hope you all enjoy it. Make sure you go through it. And if you have questions, you can send it to me directly in the different platforms that we have available. So once again, I want to wish you a very pleasant day. Enjoy your day. Bye.